Okay, let me introduce Hrittik Roy, platform advocate at Loft Labs from India. And so he likes to create an impact on communities, either by part of coding or content or mentorship. Hrittik is going to give us a presentation as part of this DevOps and cloud track, about 15 minutes, also on multitenancy made simple, what it is and why it matters. Can I have a round of applause for Hrittik? Thank you.
So hi everyone, this is my second time in FOSSASIA. I was there last time and I was very excited about this event. So last time I talked about cloud development environments, but there is a overriding problem about how we can save cost and how we can have multi-tenant architecture. Before I start, a bit about me. I'm Hrittik Roy. You can connect with me at Hrittik here. And I'm a platform advocate at Loft Labs, a CNCF ambassador. And I've done a couple of certifications and I like talking about things that interest me. So today, when we talk about multi-tenancy, Kubernetes and all those areas, we need to understand what Kubernetes is. So first important thing we understand is it is an abstraction layer. And apart from the abstraction layer, it is more about cost abstraction as well as compute abstraction. So you abstract away your cost because all of the things you are creating is created on parallel as well as compute resources as well. So as a large-scale distribution system, wherever a cloud company comes into the picture, they care about making it simple. The reason being, each node is a revenue generator. Apart from that, each control plane, like the control plane cost you pay, is also a revenue generator for them. So most of the cloud providers and most of the providers focus on making it as simple as possible. So right now, you can go and spin up a cluster with hundreds of nodes, and it is as simple as that gets. But there is a problem with that. The problem is, now, if it's so simple, you can have a cluster for every customer, every team, every member, and that creates hundreds of unnecessary cluster. With so many unnecessary cluster, there's a cluster toil, and we need to consider a couple of more things over there. The first thing is, suppose you have a number of cluster per team, per developer, per department. There are two types of costs we care about over there. The first is the cost to run the hardware, and the second is the maintenance cost. As your number of clusters scale, both of them scale together. Like for example, if you have hundreds of clusters, you pay the cost to run those applications. Like for example, if you are running Argo and all, you pay for that. But apart from that, you pay for things that are running again and again. Like for example, cert manager across all of your clusters. So as you see, there are a lot of costs associated, but there comes something called multi-tenancy in the picture. So if we talk, it's like multi-tenant city, if you break down it to the lowest level. And to explain what is that, I have a simple example for you. Suppose you live in a flat. What we do over here, you have resources that are managed by your flat provider, as well as you have all those abstraction layers of security and everything. You don't care about that. Your tenant cares about that. And you can go and stay in your flat. You can have all those resources, and you don't need to manage most of the plumbing and all those things. On the other hand, we have a home where there are a couple of problems. The problem is, suppose you are renting it. You need to create new doors, new parameters and everything. And apart from that, you need to manage your own plumbing. You need to manage your own electricity. So as you see, there are two domains. At one place, everything is managed, but it's less secure. On the other place, where you have a home, your things are smoother, but again, you need to have stronger abstraction layer if you are allowing anyone else. So whenever we talk about multi-tenancy at basic level, we talk about three specific categories. One is workload isolation. So you want your workloads to be isolated from each other. You don't want your customer data to be moving from one to another. Tenant autonomy. Whenever your tenant is running, you need to have the full permission for them. It's not like that your tenant can't have privileged permission inside your cluster. And last is fair usage. You don't want your single tenant. Maybe it's a team, maybe it's a customer, maybe it's anyone else to consume all the resources you have. All those pillars are important for you to perform in a multi-tenant architecture. And when we dive deeper into this, there are a couple of ways we can approach this. So before we approach the ways, let's understand the definition. So it's a big definition, but at the end, the goal is to share a cluster or share an environment between different teams or between different resources or between members. And currently we do it in two ways. The first way is focusing on namespaces. So how many of you have heard about namespaces over here? Kubernetes namespace, one of the most basic Kubernetes resources. So it's a simple resource, and a lot of things are not isolated over here because you are just creating a virtual abstraction. You can add a lot more things over here, like IP blocks and everything. But suppose you are deploying a CRD. What do you do that? It's a cluster level object resource. So you can't isolate that, and that is the problem. But apart from that, there are other problems as well. These are the list of problems. Like for example, as your number of tenants grow, you can create n number of namespace, but how do you manage the conflict between different CRDs? And then how do you distribute different Kubernetes config per team? It's a single config, you can add a lot of layers and everything, but again, you need to give the access to your config. And suppose one of the config is exposed, then how do you make sure that all of your environment is safe? So generally, namespace isolations are good when there is trust in the tenant, but apart from that, resource sharing and everything is hard to manage. And when you have growing number of customers whom you are sharing a cluster with because they have their environment running over there, it's complicated. Then the next thing is, the next type of multi-tenancy is where you create different clusters. But the problem is here is the cost. So you can have n number of cluster, but with n number of cluster, you pay n number of control plane cost, like the cost you pay EKS for running your clusters. The platform stack cost, for example, you're running cert manager one time in a cluster. You need to run it 100 times. So it's 100x the compute cost of one cert manager. And the last is workloads. Workloads are similar cost of how many times you're running. So that doesn't matter that much. But apart from that, the most important thing when your teams are growing, the complexity grows. How do you make sure your clusters are being killed when it's not being used? How do you make sure your cluster is as simple as possible for your administrative layer to manage? It's hard. And the most important thing which we have noticed when we were experimenting about this technology was, as you are distributing your workloads across different geolocation, billing and tagging becomes very difficult with more clusters. So what do you choose? Like, do you choose namespace? Do you choose clusters? How do you create a multi-tenant architecture in your system? So the approach which we came up with was segregating your platform stack and having a virtual cluster, like as we have a virtual machine, which is using a hypervisor on top of your cloud infra to create virtual machine, we use the same approach to create a virtual cluster. And the way we do this is open source virtual cluster. So we are an open source GitHub project with 10.5 thousand stars, and we are focusing on a specific multi-tenancy problem. And the problem is, you can scan the code to go to the website, but the problem is as simple as that. So we create a host cluster, which you bring in. It can be EKS, it can be your GKE or anything as such. And then what we do is we create a namespace and make sure we enforce the isolation layers. Everything is stored over there, and your applications and everything, including CRDs, are synced back to the host cluster. But the advantage is you are not creating more infra. You are using the same infra. It is as simple as deploying a namespace, but you get the advantage of having stronger isolation control. You can isolate your networking layer, you can isolate your CRDs, as well as you can isolate your storage provisioners. So as you see, you are having virtual clusters. And if we go back over here, like in a simple example, you run your cert manager, Vault, Argo, all of those things again and again. What you can do is save the control plane cost by moving all of those repeated platform stack at one place and creating your virtual cluster and all those components inside each of the vClusters. So what you get is simplified Kubernetes cluster management. But apart from that, the best thing is like you can sync your resources. For example, if you're running a vault, you want to sync the secrets and everything, or if you're running an ingress controller and you want to sync your ingress classes and ingresses up and down, that can be as easy as just configuring that into a YAML. So as you see, your administrative layer is doing all those things, but as a developer, you just focus on building, deploying, and running, and doing the most important part of your job is creating business impact and value. So whenever you think about vCluster, what you get is you bring in a simple layer of your host cluster, and you can have multiple virtual clusters on top of that. Most of the times, whenever you need a cluster in your org, the problem is you don't have enough access in the cluster because it is divided, and it also takes a lot of time to get it. So with the full cluster admin access in top of your virtual cluster, your team can have a host cluster, and you can have all those virtual clusters identifying and deploying things. The third part is we use a lot of CI and all those things. And the problem is it takes time to deploy Kubernetes, and it wastes the action minutes and all those things. So as it is creating a namespace only, so it deploys as fast as a container. So whenever you are using that, your CI pipelines can be faster. And then the couple of capabilities is like you can choose what type of isolation you want. Do you want to isolate all of your resources? Do you want to isolate all of your networking? Do you want to isolate all of your storage? So that is the power you have. Next is self-service. The goal is to, like whenever we talk about user experience, it is a popular goal. But whenever we talk about developer experience, most of us don't care about it. So the goal is to improve the developer experience for developers so that they can come in, request a cluster whenever they want, test whatever they want, and then go forward to do their work. Last is, whenever we think about vCluster, a way to create quick clusters, what can be a few use cases? First is quick CI. For example, you have a virtual clusters in top of your pipeline, and with that, you can create quick CI so that your testing and everything can be done easily and faster. Next is testing environments, full-fledged testing environments, which mocks your real environment. That can be done because you configure everything in a YAML. Last is environments with different CRDs. As we were discussed, you don't need to go and create new CRDs every time for every cluster, for every environment. You can have virtual clusters which do that for you. And last is, whenever you have a node pool and you want a specific team to have specific type of Kubernetes compute resources, you can specify that, and your virtual cluster manager, which is vCluster, can issue those type of nodes to those type of clusters, and then you can use that. Nextly is, this is about me, so you can connect with me and learn more about what we are doing. And if you have any questions, we have some time for that. Feel free to ask me, and I will be here.
Yes, absolutely. We have some questions. Oh, we have time for questions. Yes. Over there.
How you deal with performance if provision multiple cluster, it would create the overlay network or not?
Yeah, so the way we, it goes back to the architecture layer. So what we do is, we don't create actual clusters in top of your cluster. What we do is, we create a virtual namespace, and then whenever you create a networking layer or pods or anything, we sync back that to the host cluster with some labels and everything, so that whenever you are using, there is no bottleneck. For example, if you are using a etcd a server on top of your host cluster and it's getting thousands of requests because you are creating a lot of secrets. With virtual cluster, you will have dedicated API server for each of your whole virtual clusters. So the requests will go through them, and it will actually underburden the host cluster. And then again, there is a syncing capability. For example, if you have ingress in all of your hosts and virtual, you can sync whatever you want so that to balance out your burden. Yep, thank you. And any other questions?
Was there a question at the back somewhere? No? Okay. Oh. Yeah, happy to take one more. Otherwise, I think we're good, and that was informative. Thank you very much.
Yes.
Oh, one more. Yes.
Can you just Can you just please repeat the question?
Okay, if we want to run the cloud FinOps tool like kubectl, can it measurement on the
Yeah, we have an
cluster?
integration for kubectl as well. So it's in the open source version as well. So you can integrate with it. And then we are building an internal cube dashboard so that you can measure the cost you are saving, both on the platform stack, both on the stack of how much cost you are saving by using virtual control plane instead of the actual control plane from the cloud providers. So that can be done. If you are more interested, I can help you to learn more.
Thank you.
Thank you so much, everyone, for having me in
Thank
my
you.
talk.
Round of applause.